Hello friends, welcome to another video of Zeta Axis, and today we are going to discuss about petroleum and natural gas reserves and production in India. We have already seen in our previous video how natural gas and petroleum are formed. There is an ocean, there are living organisms, and over a time these living organisms they will die and a layer will be formed on the ocean floor. Several other layers will be formed on that layer, and it will be under the pressure and heat generated by the overlying layers. The undecomposed body of these organisms, it will be converted into petroleum over several millions of years, and this petroleum is then extracted from a well. Here is the process. There is an anaerobic decay. The marine organisms die and there is a slow anaerobic decay. Then there comes a kerogen formation, which is a thick wax like material. Then it goes catagenesis and then it forms oil, which is then extracted. This is how whole cycle is completed from marine organisms to formation of oil. In our previous video, we saw that petroleum is mainly found in the regions where there are marine organisms living in ocean. Now, marine organisms live in maximum amount in the continental shelf of continents, and therefore petroleum has higher chances of being found in the regions where there is a continental shelf or where there was a continental shelf. Here we can see these are the continental shelf of Indian subcontinent. We also know that before collision of Indian plate with Eurasian plate, there was Tethys Ocean. So there was continental shelf over here. And that is why we can see that in some of these regions, we also find petroleum. Now here are sedimentary basins of India. Some of them are current continental shelf, while some are continental shelf from the past. So Indian government has divided them based on three categories. First is basins which have reserves and are already producing. So these, in this light blue color, all these basins are currently producing petroleum. So these are category 1. Then there is category 2 basin which have contingent resources pending commercial production. So category 2 basins are those basins where already some discoveries have been made but no extraction is done. So these in the yellow are category 2. And the category 3 are basins which have prospective resources awaiting discovery, where no resources have been discovered but there are chances that there will be petroleum in these sedimentary basins. So these are in orange or this pink color. Now here are category 1 basins. They are mainly Rajasthan Basin, Can Bay, Mumbai Offshore, Krishna Godavari Basin, Kaveri Basin, Assam Arakan Fold Belt Basin, and then Assam Self. So these are the category 1 basins. And these are the oil fields. You can see these are already discovered oil fields, and the yellow colors they indicate the stations which are producing petroleum or natural gas. These are the category 2 basins: Mahanadi, Vindhyan, Saurashtra and Kutch, where some contingencies have been found but no commercial production is going on over here. And finally, these are the category 3 where no contingency has been found or no petroleum or natural gas has been found, but there are good chances of some of them existing over here. So they include Spiti, Janskar, Karewa, Himalaya, Four Belt. Then we have Ganga, Punjab, Plain, Bengal, Purnia region, the Satpura, South Rewa, Damodar Basin, Chhattisgarh, Pranhita Godavari Basin. Then we have Deccan Syncline, Narmada, Bhima, Kadapa and Kerala basin. So all these basins, there are chances of existence of petroleum. Now let's see some data and statistics related to petroleum and natural gas industry. If you see the global oil producing countries, then United States is at the top, followed by Saudi Arabia and Russia. India is at 23rd. So India is not a major petroleum producing country. Similarly, if you see the global gas producing countries, then United States and Russia are at the top and India is not in the top 20. If you see the crude oil importing countries, countries which import crude oil, then China is at the top, followed by United States. We know that United States is a major producer of oil, but still it also imports oil because of its national planning. Now India is at the third biggest importer of oil. Similarly, when we come to natural gas, we see that China is the largest importer of natural gas, while India is at the 8th position. Now, if we see the national production of oil and gas, then we can see that for crude oil, the production is divided into offshore and onshore basins. So we see that Western offshore is the major producer of oil in India. This is the Mumbai high region which comes in this category. Then within onshore regions we have Rajasthan, followed by Gujarat, and then Assam. So these are three majority oil producing states, but most of the production of oil comes from Western offshore. Similarly, when we go to natural gas production, and we can see offshore and onshore. So for offshore, Mumbai offshore is the highest natural gas producing region, followed by eastern offshore. Here the Krishna Godavari basin is incorporated in this section. Then we have Assam, Rajasthan, Tripura, and Gujarat as the major gas producing states in India. Here there is West Bengal, Madhya Pradesh, and Jharkhand, and these produce natural gas in the form of coal-based methane. So here there is different type of non-conventional natural gas produced. Now if we see the import dependency, that is of the total consumption, how much we have to import. So for oil, our import dependency is 88%. So of the total oil that we consume, 88% is imported. But if we see natural gas, then the total natural gas that we consume, out of which only 51% is imported. Then let's see the share of oil in import of our national imports. So if we are importing 100 items, then 25% share is of only petroleum, that is 1/4 of the total items that are imported by value are petroleum. And if we see the export, yes, we also export petroleum products because we have refineries and the capacity of refineries is more than what we required. Therefore, the extra products which are gained from these refineries are exported. So in export, the petroleum has a share of 12%. Now, if we see country-wise oil imports, that is the regions from where India imports oil. So Russia currently is at the top, followed by Iraq, Saudi Arabia, UAE, and USA. And if we see country-wise gas imports, that is natural gas imported from countries by India. So Qatar is at the highest, followed by UAE, Saudi Arabia, Kuwait, and USA. Now there are some other matrices that you must know. That exporter of refined products. So India is at 7th position. This is because we have a large number of refineries. Ethanol blending in petrol, we are at 2nd position. Biofuel producer, we are at 3rd position. LNG, that is liquefied natural gas terminal capacity, we are at 4th position. And refining capacity, total oil refinery capacity, that is we are again at 4th position across the globe. Now let's see what are the different types of crude oil. We will see the different terms which are used to define the crude oil. So the first is light oil versus heavy oil. Basically, there is a quantity, API gravity, which is used to measure oil weight. Now, this API gravity was formed by American Petroleum Institute, and it measures the density of oil. Higher the API, lighter is the oil. Lower the API, heavier is the oil. Now here, lighter the oil, it is the of better quality. So lighter oil has higher price, heavier oil has lower price. Light oil requires less processing. It produces a greater percentage of gasoline and diesel than heavy oil, while for heavy oil it evaporates very slowly. It contains material that will be used to make heavy products like asphalt. Now there is another term, sweet or sour crude oil. Sweet crude oil has very low levels of sulfur. It is under 1%, while sour crude oil has 1 to 2% of sulfur. Extra treatment is required if the sulfur content is higher. Therefore, sweet oil has higher price. Here you can see the level high sulfur level, it is sour, and low sulfur level, it is sweet. So the sweetness increases as the sulfur amount decreases. Next is TAN count of crude oil. TAN means total acidic number. So this basically represents how corrosive the crude oil is. And if the crude oil is highly corrosive, then the equipments should have robust metallurgy so that it can withstand the corrosiveness of this oil over time. There is the TAN count. It says, you can see if higher the number, higher the TAN count. Now here we can see categorization of oil produced by different regions. So here we can see there is API gravity, and higher the API gravity, lighter is the oil. And here we can see sulfur content. So lesser the sulfur content, more sweeter the oil is. It is more better. So if we see, the oil produced by Malaysia and Algeria are of best quality, followed by United States WTI, that is Western Texas, and then United States LLS. And if we go up in this corner, then the oil produced by this region is of worst quality. That is, these are the least good quality oil. So in here we can see Saudi Arabia, it has very high sulfur content, as well as the API is on the lower side. We can also see North Sea region over here. This is the region between Norway and United Kingdom, where the oil is produced. So even this oil is of good quality. Then there are certain benchmarking of oils. So WTI, it is Western Texas Intermediate, it is produced in United States, and it is lighter and sweeter oil. This is the best quality of oil. Then we have Brent oil, that is produced from Scottish Brent and Nina systems located in North Sea. This is the North Sea, that is between United Kingdom and our Norway and Sweden. It is light and sweet. It is also of very good quality, but slightly lesser than the WTI. And then we have finally OPEC, where OPEC is a group of 7 countries. And here there is heavier and sour type of crude oil is present. Now let's see some oil and gas stations in India. So here is India, and these red dots, they indicate the stations within India. We can see that the stations are spread right from Rajasthan to Arunachal Pradesh and Assam. We have some offshore stations both in the Bay of Bengal as well as in Arabian Sea. So here we start with Assam, where we have one station in Nagaon district, then we have one station in Majoli, then we have Jorhat district, then we have Sivsagar, where we have one station, and then we see that in Dibrugarh we have several stations, and then we have Tinsukia district. So Tinsukia and Dibrugarh are the major oil producing districts of Assam. These are the name of these stations, and we have here Greater Naharkatika, which is an important station. Then in Arunachal Pradesh, we have one station in Changlang district. Here in Maharashtra, or on the offshore of Mumbai, we can see that there are several stations. Here we have Basin region, and we have one station over here. This region is where Mumbai is located, and these are the stations in the ocean. Here we have Hira and Neelam, which is very close to Mumbai, and then we have Ratna, which is over here. Then there is Tarapur station over here, and then in Daman also we have one station. Here is the map of Gujarat, and here we can see that there are stations in Surendranagar, Banaskantha, Ahmedabad, Anand, Bharuch, and there is also one offshore station over here. These are the names of those stations. Here we have a Canbay station, which is controlled by ONGC, and here we have Ankleshwar in Bharuch. This is Andhra Pradesh, where we can see that there are several offshore stations, as well as there is this onshore station in Rajamundry in YSR district. There are also onshore stations here in Konasima district, and remember, this is the region where the Kaveri and Godavari Delta region is there. So this is basically Kaveri Godavari basin region, and therefore we can see that it is also an important basin for oil and gas production. Here on the coast of Odisha, we can see that there is one offshore station. Here is Rajasthan, and we can see that within Rajasthan there are oil stations in Nagaur, Jodhpur rural, Balotra, Barmer and Jaisalmer, right at the border. Here we see that within Jaisalmer, near the border, we have Dandewala station, and in Barmer we have Rakeshwari deep gas station. In Tamil Nadu, again we have two stations. One is in Perambalur and another is in Mayiladuthurai district. It is called Kaveri, and this is Puthalam. This is basically Kaveri basin in which we have petroleum. Then we have Tripura, where we have Dhalai district, in which one station is there, which is called Tripura station. And then we have this Tichna station in Sipahi Jala district. Now we will see production of coal bed methane. So we have already seen that how coal bed methane is created by decomposition organic material under pressure and temperature. So when the living organisms, or specifically the plants which are living in a swampy area, they die and their body is submerged, Because of anaerobic respiration or anaerobic decomposition, their body is decomposed very slowly. And in this process, they release slight amount of methane. But because the process is so slow, several layers can be formed. And when the layers are found, because of the pressure of those layers, this methane which is produced by the anaerobic decomposition, it gets trapped in the coal. So it is, you can see that because of the pressure, the methane gets absorbed in the coal, which we can see in the figure over here. These are the coal and there is methane trapped in this. So when we remove this kind of methane or this kind of natural gas from coal, so it is called coal bed methane. And the commercial production of coal bed methane in India has commenced in 2007 in Raniganj block in West Bengal. So this is when first CBM was extracted. Now if we see the production of India, we can see that these are the three states where the CBMs are produced. Highest amount is produced in West Bengal, followed by Madhya Pradesh and then by Jharkhand. So all these CBMs or methane gas or natural gas is produced basically from coal mines. So here we can see West Bengal, and these are the stations or regions from where CBM is produced. Remember, we have a coal field called Raniganj coal field here, and it is from this coal field the CBM or natural gas is extracted from the coal seams. Similarly, in Madhya Pradesh, we have seen that Sogapur coal field is there, and it is from these coal fields in Sadhol district we extract CBM. And we already know that Jharia is one of the important coal fields. And from here also we extract coal bed methane. Now let's see refineries in India and try to understand how refineries work. So crude oil is refined based on the process called fractional distillation. Now the crude oil has several elements which are mixed together. Each of these elements has different liquefying temperature, that is the temperature at which it converts from gas to liquid. So the crude oil is input in this tower-like structure, and here at the bottom the temperature is higher, and as we go up the temperature slowly decreases. So when we rise up, we will see that fuel oil, which has the highest liquefying temperature, it will come out here as liquid, because above this region this will be in the form of liquid, and only below this it will be in the form of vapor. Similarly, when the vapor will rise up, here we have lubricating oil that will separate at 300 to 370 degrees Celsius, because again that vapor which is formed by lubricating oil, it will liquefy at this region, while others like diesel, they will still be vapor in this region, so they will rise up, but lubricating oil which has a higher liquefying temperature, it will be separated out. So as the elements move up, each of these elements will be filtered out at its respective boiling temperature or liquefying temperature. And here we can see the method which is indicated. Crude oil is heated to 600 degrees Celsius. It boils and forms vapor, which we have seen vapor enters the bottom of the fractional distillation column. As the vapor rises, it becomes cooler. Distillation column is filled with trays or plates, which collects the liquids as vapor condenses. So as this rises up, the elements which pass their boiling point, they will start to liquefy, and that is filtered out. The collected liquid fractions may pass to condensers, which cool them further, and they are stored in the tanks. So these are the refineries in India. We can see that we have refineries in Bhatinda, Panipat, Mathura, Bina, Koili, in Jamnagar, in Vadinar. Here we have 3 refineries, 2 are of Reliance and 1 is of Russian withholdings. Then we have Mumbai, where there are 2 refineries. Then Mangalore, Kochi. Here also there are 2 refineries, but both are operated by same company. Then we have Nagapattinam, Chennai, Chattipaga, Visakhapatnam, Paradeep, Haldia, Barauni. This is also important. Bonaigaon, Guwahati, Numaligarh, and Digboi. Now each of these refineries, we can see they are connected through a national pipeline grids. Now if we see the nature of those refineries, that we can see that most of them are public. However, here in Jamnagar, all the 3 refineries are private, and here also we have in Bina, it is of private. If you see the capacity of these refineries, that we can see that refineries at Jamnagar has the highest capacity. Here there are 2 refineries which are very big refineries, and they are currently Asia's as well as I think world's biggest refinery. Here we can see the refinery capacities in the form of this vertical column. So we can see that clearly all the three refineries at Jamnagar, one is at Jamnagar SEZ, one is in Jamnagar DTN, and another is in Vadinar. So all these three refineries have very high capacity. And then we can see that refineries at Panipat, Paradeep, Visakhapatnam, Mangalore, Kochi, Goregaon, they also have higher capacity. These are the names of the companies which are controlling those refineries. We can see that here two are from Reliance, and then we have this Nayara Energy, which was earlier SR Oil, but SR sold it, and now a Russian company owns this Nayara Energy. And also here we have Bharat Oman Refinery, so this is also a private owned refinery. Now let's try to understand what is liquefied natural gas. So when the natural gas, it is cooled and converted into liquid, then it is called liquefied natural gas. And this is important because liquefied natural gas consumes 1/600th of the volume of natural gas, and it is also safer to transport compared to natural gas. So whenever there is a gas field which produces this natural gas, so it can liquefy it, it can store it in a ship, and then it can transport it easily, and at the station it is again deliquefied and then transported in the pipeline. So this is one of the major ways in which natural gas is transported across the world. And if you see the leading LNG importing countries, then China is right at the top and India is also at the 4th position. These are the LNG terminals across India. And here we can see that all of these LNG terminals are connected through a pipeline. The LNG terminals in Gujarat, we have Mundra, here we have 2 LNG terminals, and then we have Dahej, where we have 2 terminals. Then there is LNG terminal in Hazira, Jafrabad again, there are 2 terminals, and then Chara LNG port. Within Maharashtra, we see Dabhol, where there are 2, in Jaigarh again 2, and then Mumbai port. Then in southern India, we have at Karavar, which is in Karnataka, then in Mangalore we have 1, then Kochi, Karaikal port, and Ennore, where we have 2 LNG ports, and then we have Gangaram in Andhra Pradesh, Kakinada. We know that this place is important for natural gas production because here we have Kaveri Godavari basin. So here also there are 2 LNG stations. Then we have Dhamra and Digga. Now let's see oil and product pipelines across India. So these are the total network of oil and gas pipelines. There are several others, but these are the important ones. We will see closely some of the important ones in them. So there is a pipeline which is called Panipat Ambala Jalandhar pipeline, which connects Jalandhar, Ambala and Panipat. And we have also Panipat to Bhatinda, one pipeline in the northern India. Then on the eastern India, we will see there is a Pradeep Haldia pipeline, where Haldia and Pradeep are connected. Then we have Pradeep Rajpur Ranchi pipeline. So this pipeline, which originates from Paradeep, it goes through this region and then it connects Korba, Raipur and Ranchi. So it connects 3 of these cities. Then there is a Pradeep Hyderabad pipeline. So this is a very long pipeline which starts from Paradeep. It passes through Srikakulam, Visakhapatnam, it goes through Vijayawada and then it reaches Hyderabad. So this is also a very long pipeline. Then in southern India, we have Ennore Bengaluru pipeline. It starts from Ennore and goes till Bengaluru. Then we have Ennore Madurai pipeline. In the west, we have a pipeline which starts from Mumbai, goes through Panvel, Pune, and then Solapur. And then in northeast, we have Siliguri to Guwahati pipeline. Again, in the northern India, we have networks of pipelines which connect Haldia to Mathura. Here we can see that there is a pipeline Haldia Barauni. So remember, Barauni is also a refinery. So this pipeline connects Barauni refinery to Haldia. Then there is a pipeline from Barauni to Kanpur. And there is another refinery in Mathura which is connected to Lucknow. This is Gavaria is very close to Lucknow. So it passes through Agra and then Gavaria. There are also other important oil pipelines in India, but I have covered only the one which I felt important. There could be other which you would feel important, so you can read it from some other source. Now let's discuss gas pipelines of India. Here we can see the total plant and operating network of gas pipelines in India. Here are the different colors which indicates the type of pipeline, whether they are operating, they are planned, or they are under construction, or they are non-operational. So each of these colors indicates the status of that pipeline. So we will see the important gas pipelines. The first is HVJ or Hazira Vijaypur Jagdishpur pipeline. This is the first gas pipeline of India which was started in 1984 after incorporation of GAIL, and it aimed to supply gas to fertilizer plants located in Uttar Pradesh. The total length is 1750. This is non-branched length. If branches are counted, then it increases above 3000. This is a very important gas line. It starts from Hazira right in our Surat. It goes to Vijaypur, Auraiya, Kanpur and Jagdishpur. Then another most important gas pipeline is East-West gas pipeline, which is basically Kakinada, Hyderabad, Uran and Ahmedabad. Now there are basically two phases. One is operated by Reliance, which goes from Kakinada. Kakinada is over here. We have seen that this is the KG basin, Krishna Godavari basin. So it takes the natural gas which is produced from here and it passes it via Hyderabad to Uran. Here we have pipelines of GSPC, that is Gujarat State Petroleum Company, and it has branches from Uran to Bharuch. So then it is connected and it is passed to Bharuch till there, and then to Ahmedabad. Here is the pipeline that we are talking about. So here you can see that there is Dahej, Uran, Panvel, Dabhol pipeline. So it's here is Dabhol, then we have Uran, here is Panvel, Hazira and Dahej. So there are networks of pipelines which are connecting the western coast. In the northern India, we see that there are plant pipelines reaching to Srinagar and Jammu, which originates from Bhatinda. There is one pipeline from Mehsana to Bhatinda, where Mehsana is in the northern Gujarat. So this is also a very big pipeline which is under construction. It will connect Mehsana to Bhatinda, and then these are the plant pipelines which will bring gas to Srinagar and Jammu. Here we have Nangal and Panipat and Bhawana Dadri pipeline. Bhawana is near Delhi, while Dadri is in Gautam Budh Nagar. Then in the eastern side, we have a pipeline from Barauni to Guwahati. So we have connected it with a gas pipeline. And in the south, we have an important pipeline and node to Tuticorin. This is also a port region. Again, in the western side, we have pipelines connecting Dabhol and Bengaluru, and then we have pipeline connecting Jaigarh to Mangalore. This is under construction while this is operating. Now let's discuss about shale gas prospects in India. Right now, there is no current commercial production of shale gas in India. So let's discuss about the reservoirs. So the reservoirs in India can be divided into large-scale deposit and small-scale deposits. So large-scale deposits have been found in the sedimentary basins of Cambay, which is this one. Then we have Assam Arakan, that is this one. And then we have Damodar, which is this one. And small-scale deposit estimates are found in Gangetic Plain, this one, Gujarat, here, Rajasthan, Andhra Pradesh, and other coastal regions. Now, different companies have put forward different estimates. So we have estimate of ONGC, which says that 187.5 TCF of shale gas is present in 5 basins, and it gives on the names of those basins, that is Cambay Basin, which we have seen over here, Ganga Valley, Assam and Arakan, Krishna Godavari, this region, and Onland and Kaveri Onland. So this is also Kaveri Onland Basin. There is a Central Mine Planning and Design Institute. So it has also given its estimates, and it says that there are 45 TCF of shale gas in 6 sub-basins, and these are Jharia, Bokaro, North Karanpur, South Karanpur, Raniganj and Sohagpur. So these are basically coal mines, and there are estimates of shale gas present in it. And then USGS, which is United States Geological Survey, has also given estimates of 6.1 TCF in 3 basins, that is Cambay, Krishna Godavari and Kaveri. So right now there is no commercial production of shale gas in India, but government has issued policy guidelines for exploration and exploitation of shale gas and oil by national oil companies. So remember, only national oil companies can currently exploit shale gas. The right to exploration and exploitation of shale gas will lie with the NOCs, that is national oil companies holding petroleum exploration license. So only the national oil companies right now have the right. ONGC and Oil India, these are the 2 companies which carry out shale gas and oil exploration. So they are right now exploring in 50 and 5 blocks. So 50 blocks are given to ONGC and 5 blocks are to Oil India. ONGC is carrying out shale gas and oil exploration activities in these basins: Canbe, Kaveri, Krishna Godavari, and Assam Arakan Basin. While All India is carrying out shale gas and oil exploration in activities in Assam and Rajasthan. So the important ones are with ONGC and others are with Oil India Limited. Now let's see some government initiatives which are related to promoting petroleum production in India. The first is Pradhan Mantri Jeevan Yojana. Here it supports bioethanol projects such as second generation and third generation plants for sustainable fuel production. So it helps in establishing bioethanol projects. It is called Pradhan Mantri Jeevan Yojana. Then we have strategic petroleum reserves, in which 3 underground storage facilities are placed in India. So if there is any global shortfall of oil, then we can use those storages. It is located in Visakhapatnam, Mangalore, and Paddur in Karnataka. So these are underground storage facilities where this much amount of crude oil is saved. Then we have ethanol blending program, and remember, under this program we have to blend 20% ethanol blending in 2025-26. Then city gas distribution network expansion. So by this we are providing piped natural gas supply to users. The scheme wants to achieve this goal, that is 733 districts in 34 states and UTs, covering almost 100% of the mainland area and almost 100% of total geographical area of the country. And energy security initiatives. So this is basically investing opportunities in overseas exploration and acquisition. So Indian companies, they can buy offshore units and do exploration in those regions. So this is also an initiative. Then there are some initiatives for greener fuel. One is called Satat Initiative, or Sustainable Alternative Towards Affordable Transportation. So it promotes in setting up compressed biogas production plants. It wants to increase the use of agriculture residue, cattle dung, and municipal solid waste. Then there is Mission Green Hydrogen, which promotes green hydrogen production to reduce carbon footprint. Then we have National Bioenergy Program, which focuses on bioenergy production and reducing waste. And then we have Hydro Exploration and Licensing Policy, which is called HELP. It encourages private investment in exploration and production. So this HELP is for promoting private investment in exploration. I hope you have liked our video. We have tried to cover each of the aspects of petroleum and natural gas industry. If you have liked the video, then do subscribe to the channel and share it with your friends. And if you like what we are doing, then you can support us using the Paytm ID. Thanks for watching the video.